I do video or
Yeah,
no?
yeah, that would be great.
Okay, let's see if video works.
Oh, there we go.
Okay.
We are in the
Hi.
presence of the professor. How's it going? How are you
I'm the
feeling about
professor.
everyone saying hi? How
Hi.
are you feeling about how the book's going so far?
Oh, it's out,
Yeah.
and people seem to like it. I think it's not out yet. I mean, the hardcover doesn't really officially come out till March 2nd. So I'm pleased with it, and I'm pleased with the reaction of the people who read it.
Yeah.
And we'll see what kind of impact it can have. But yeah, it seems to be I'm not surprised to hear that it seems to be more widely received now in England and Europe than in the U.S. and maybe in Canada. But we'll see. That wouldn't surprise me.
Right. Right.
And so I've been a long day. I started the day at 7 this morning doing 2 broadcasts with BBC and radio stations
Nice.
in the UK.
Great.
And I just finished a podcast in the Middle East, and I'm going to do one in India tonight. But I haven't done any radio interviews in the US or Canada, and at this point there's no expectation of doing that. So
okay, cool.
We'll see.
Awesome.
Why is that?
Dal,
why is that? I have no idea. Well, I mean, there's some ideas, but I think I think that when it comes to issues like this, which are where one's talking about science rather than controversy, there's not so much interest in the U.S. Anyway, it's not up for me to decide.
Yeah.
Any speculation I make is just pure speculation. All I know is that there seems to be much more interest in general in when I do things in Europe and England than in the U.S.
Yeah, definitely. Dal, do you mind muting? Just we can hear those beautiful birds, but I just yeah, thanks. That's great. Okay, well, I'm going to start with the first question. Lawrence, I have the one of the shirts on we made in 2017 for when we were doing some events.
I see it.
The Krauss goggles right there.
Yeah.
So I'm almost finished my review that I'm writing of the book, and I'll post at thewarofideas.org. This is one of the questions, or one of the statements I make, I guess, after reading the epilogue and one of my responses. So here's a claim I'm willing to make, and I just want to know if you agree with this claim.
I disagree.
I knew it. All negative effects on humanity as a result of climate change can be overcome by human technology. And the examples I give to follow that up are city-scale biodomes, ocean-to-city partitions, alternative food sources, atmospheric carbon vacuum, self-replicating nanorobotic ocean life feeding with an off switch, of course, et cetera, et cetera, et cetera. So do you think...
Look, I mean, well, I mean, if you want to do science fiction, the answer is yes. When it comes to science fact, I doubt that the answer is yes. Well, first of all, the answer is we don't know, right? You don't know until you try. So how can you make a statement about all things can be overcome by this when you don't know? So it's kind of a religious statement in a way. So you can try, and we'll need to try, because there will be lots of effects. But the world is a complicated place, and there are lots of effects you can't anticipate, in particular socio-political effects. So you are correct in the sense that I don't think the problem is a technological one. The problem is a political one.
Well, I agree with that.
Well, of course you agree with it. I'm right.
Well, okay, cool. Well, let's move on to Scott Lassiter. Scott, you're up, buddy. What question you got?
Man, I'm actually not quite prepared yet. I wanted to listen a little bit before.
Okay. That's cool.
Okay. Yep.
Well, we can.
Everyone's got their animals.
Yeah. Everyone's got
mine is down below me right now, sleeping right at my feet.
Right at the feet. That's where they love to be.
Michaela.
Oh, sorry, Scott. Go ahead. Yeah.
I was going to say, I guess maybe, can you give us, I don't know, in your own words, like a rundown on the basic ideas that you're trying to get across with the book?
Well, yeah, sure. I mean, the basic idea is that climate science isn't rocket science. that understanding the basics of climate change don't require you to have a supercomputer, that the basics physics and chemistry is almost 200 years old, and it's fascinating, the history of the red herrings and how we came to understand it. So I think, like much of the science I've written about, it's interesting to learn in its own right. But basically, you can understand quantitatively what the key predictions of what the key impact of rising carbon dioxide is in the atmosphere, with high school physics, and that gives you the power to realize what predictions are written in stone and which ones are more speculative, and so that's one of the things that I guess I want to get across. The other is that there's things that are unexpected, that about climate change that are non-intuitive, that are not so that there are many misconceptions based on notions of the scale of human activity compared to the scale of carbon dioxide. Where the action takes place in what you call global warming isn't at the Earth's surface; it's at the top of the atmosphere. And another one, that the sea level rise is primarily due to glacial melting and ice cap melting, when in fact a large fraction of it is just due to the simple physics of water, which has been heated up. And when water heats up, so a half a meter of sea level rise this century is written in stone. We've already put the heat in, and so that's not going to change. So there's some things that we can't change, and those things we need to figure out how to mediate, as Travis was talking about. But for the things we might be able to affect, we also have to realize that the other important thing is that the carbon abundance remains the same in the atmosphere. The carbon abundance has a half-life of about 1,000 years. So every year when we put 10 billion tons of carbon in the atmosphere, as we're now doing, about 5 billion of its 5 billion tons more or less stay there for 1,000 years. And every year we wait to act means it's another. We have to be more dramatic in our further cuts if we want the total to remain the same. And I think those are some of the ideas I wanted to talk about. But of course, there's a lot more. And I guess I wanted to show people that they can understand this, and that's the basis for rational action. That you need to understand what's imminent, what's certain, and what's less certain, and decide what the risks are, and then you can take rational action. So my hope is my book will take people to the precipice of rational action, which is why we're sending 600 copies to every member of Congress at the end of this year. At the end of this, the end of this month.
Interesting. Okay, Michaela, let's go with you. You're up next.
So
Hi.
again, it's always a pleasure talking to you, Lawrence.
Nice to see you, Michaela.
Nice to see you too. When you talk about things, like when you talk about just science in general, you're always so hyped, and I wondered, like, you're just so stoked about it all the time, and I wondered, like, what gives you that drive to, you're so passionate about it, and no matter how much of a dick people are to you, you're still like, keep doing it.
Well, it's I guess I have no choice in that. I mean, it seems to me, how could you not be passionate about it? And it fascinates me, and it keeps me going, and I do what I do, and I largely do it for my own enjoyment. And so, no one could, it'd be very hard to stop me from enjoying doing what I'm doing. And so there's the other people can react as they want, but I just want to continue to do what I do, and it's fun and enjoyable and exciting, and obviously if I didn't think that, I wouldn't have been doing it for all these years. So it's better than the alternative, which is doing nothing. And since I have the opportunity still to try and have some impact, and have an audience, I feel kind of responsibility to use my voice, since I still have a voice. It hasn't, and as long as I have one, and even if I don't have one, I still will continue to do what I wanted to do, and I'll do it largely because it's you may have seen my recent dialogue with Woody Allen, and it's just pushing that rock up the mountain, and for me that makes it all worthwhile, even if it rolls down at the end.
Incidentally, The Myth of Sisyphus is that book that I keep in my backpack, hoping to absorb it through osmosis.
Okay, yeah, well, that's right, and yeah, there we go. And I think I have a lot of books on my shelf that I hope to absorb through osmosis. So it really, just owning them makes you feel better. So I can understand it. But that myth impacted a lot on me when I was very, very young, and when I sort of when existentialism, I guess, first impacted on me when I was a teenager, and. But I think it's true. I think it's what enjoying. All of us should be excited about life, and experiencing what it means to be alive, because it's only a certain fraction of time, and that makes every moment precious. So I try to, be stoked about it. I'm not always, but on the times when I'm not, you're not watching me because I'm not online.
This is Lawrence
kicking rocks down the street.
Lawrence reading his Twitter feed. You're scrolling through and you're just like, fuck, fucking Trump, fuck. Okay, he's banned. Fuck. Oh, hey, that's interesting.
Yeah, that's probably, it's not quite that bad, but I tend to not go far. It doesn't matter. I don't get as emotional about the NAD ones. It's easy. It's fun to block people every now and then. That's enjoyable, I guess. But most often it's just useful to just ignore them. So,
Dal Su, you're up, brother.
Thanks for talking to us today. My question is basically, if you were dictator of the world, what would be the first action you take against global warming?
Well, okay. I don't think, I hate to say it, but I don't think in those terms. What I would do, I guess the first action I would take, I don't like the idea of being dictator of the world, but if the first action I would take probably would be to require people to learn about it.
Yeah, education, step one.
Yeah, because I'm an educator at heart, and so I've said this before, but when you're an educator, it's like the old saying that if the only tool you have is a hammer, everything looks like a nail. And for me, education is at the heart of improving humanity and the first step towards action. So rather than impose actions on people that they don't like or don't want, what I'd want to do is that people get educated so that to generate a kind of grassroots desire to take action.
Interesting. Let's jump to Bruno. Bruno, you sent a message. You got a question for Professor Krauss?
Yeah. So this isn't really in the book. I don't know much about climate change, but I just wanted to ask: is space and time, are they things of themselves? And follow-up question would be: are they real?
Oh wow. Okay. Well, I mean, they certainly exist. Okay, right? I mean, I can walk from this room to the next room, and I end up there, and my clock is ticking. So they're as real as anything you can measure. Are they emergent or fundamental? You might be asking, because they certainly exist, and we can describe the universe. Space-time is the stage on which the play of existence happens. Space-time is a stage on which events happen. So the events that describe everything in the universe happen at some point in space and some point in time. And so it's that stage. Now, is that stage emergent? Is there something underneath not literally underneath, but is there something more fundamental that they emerge from? We don't know the answer for it. But space-time is a great way of understanding everything we can see in the universe. And so it's as real as anything. But whether it's fundamental is something I can't give you the answer to. Maybe it's emergent. Maybe some fundamental thing like string theory will show why we live in a four-dimensional space-time. So far, it hasn't given any evidence of explaining that, but maybe someday it might, or some other ideas. But we don't know. And I think that's the most important answer you can give as a scientist or as a teacher or as a parent is we don't know. And but we're trying to find out. So let's all find out together.
Yeah, keep working. Desired, you're up there, brother.
Let's see if I can get my question out coherently. I tried writing it, but we'll see what happens.
Okay.
Have you put any thought into the positive effects of global warming? Meaning, if we take this as an opportunity to get some conclusion from an absolutely immoral experiment, what would be the most interesting experiment you could think of? Does that make sense?
Well, I can understand. Well, there's sort of a bunch of questions hidden in there. I mean, first of all, let's make it clear. There'll be some areas that will benefit. That'll be, some parts of Canada will be better for wheat growing than they are now. So global warming won't affect the whole world physically in the same way everywhere, and that's the first thing. So, as I said, there'll be beneficial effects in some places, and in a lot of places, not so beneficial effects. And the net effect, I think, is highly negative when you consider the interaction, the fact that no country is an island. But I suppose the experiment that we're going to carry out will be to tell us how resilient the human species is, how much you can change the environment in a way to make it hostile, and how effectively humanity can cope with that. Not just individuals, because there'll be parts of the world where literally you can't live as a Homo sapien. It's sometimes a year it'll be just too hot. But as a complex species with complex societal interactions, how well can we adjust to a radically different climate on a time scale that changes faster than say human cultural evolution has traditionally changed the human species. So that will be the experiment we're performing. But also, I mean, so that's maybe the least optimistic experiment. A more optimistic experiment may be that we're driven to do something like geoengineering, and if we do that, we'll learn something about how the world responds to geoengineering, to putting aerosols in the atmosphere, and we'll learn something, and maybe it'll be beneficial. So it's an experiment that may or may not be performed. I suspect at some point it will be. The good news is, as you'll learn if you watch my podcast and learn from my dialogue with Dan Schrag, I used to be much more worried about geoengineering than I am now, because the aerosols have a lifetime in the atmosphere of about a year. And so even if I was going to say a different word, even if we screw things up, I'll let Mikhail use that other word. But anyway, if we screw things up, after a year, in principle, those effects will go away. Now there'll be some, either way, we're going to learn more about how the world responds. And some experiments you don't want to perform because, the process of learning is so disastrous. But we'll certainly learn something.
Yeah. Can you clarify, Lawrence, what the aerosol experiments would be, like, kind of what they would look like?
Well, you could put some what you might think of as pollutants in the atmosphere, and they either reflect or absorb sunlight, and basically lead. Right now, the whole effect of global warming is encoded in a term called radiative forcing, which I describe in the book, and it really means that there's more net. I mean, the whole thing is energy in equals energy out, and if the energy in is more than the energy out, then the world heats up. I mean, it's that simple. And right now, radiative forcing means there's a certain amount, maybe somewhere between 2 and 3 watts per cubic meter, that is coming in that's not going out. And you add that up over the surface of the Earth, that's a lot of watts. So it's basic physics. But what you might do is put something in the upper atmosphere that causes less energy in. And that means that you can get an equilibrium, or maybe even cooling. If you have more, if you reflect more, and the Earth is radiating the same amount, then you may reflect more radiation and than was coming in. Namely, the Earth may radiate and cool, and so the net effect is putting some materials in the outer atmosphere, either aerosols that absorb or some reflectors that stop that energy from getting through into the atmosphere, and maybe cause cooling that counteracts the warming that would otherwise be the case because of increased absorption by infrared radiation within the atmosphere coming from the Earth, and that happens through greenhouse gases like carbon dioxide and methane.
A global-sized AC unit.
Well, yeah, but it's not global. It's not. I'm just going to write myself something down that I reminded myself of. Okay. It's not global. That's the kind of scary thing about geoengineering. Most dealing with climate change is a global problem, and that's why no country can solve it on their own, which makes it unique in human history, which makes me on my pessimistic days assuming it won't happen. But geoengineering can be done by one country. One country can dump aerosols in the atmosphere and affect the global climate. And so you might think that's worrisome. And maybe it is, or maybe it isn't. Anyway, it's not a global, it's a global air conditioning unit, but it's produced by a local manufacturer.
So what you're saying is Futurama was totally wrong. They put the giant device. Stop.
Well, I suspect Futurama is totally wrong on many counts.
No. My life is over. Let's go to Sunny Waffles. If that's your real name. Your turn to ask a question there, Sunny. If you're still with us.
Sonny's gotten so disgusted at my remarks that I've left.
He's waffling.
Oh, no, he's on mute. Sonny's muted.
Yeah, you're muted there, Sonny.
Can you hear me?
There we go.
Yeah,
now I can hear you.
There we go.
I solved your problem,
Sorry,
Sonny. Anything else you need?
My phone just works really slow on Discord sometimes.
Oh, okay.
Okay, but so climate change. Well, my question is related to the effects because we're bad at predicting things, and I hope predicting where the planet will do is more complicated than just high school physics, right? But
locally, detailed predictions. Global predictions are not.
But we're trying
That's
to
why I
figure
can
out
predict
what
the universe.
Our effects on the planet and what it's gonna do, right? So, what do you think our effects of throwing the CO2 in the air is really gonna do to the planet to the point where we should stop what we're doing?
Well, globally, it will increase the temperature, the Earth's surface temperature, in different ways, and knowing exactly how that spans across different regions, that requires complex analysis.
We all agree on that. It will do that. It's gonna make it
Well,
hotter.
you asked me
is
what
that
it
really
will
bad?
do. Okay.
No, yeah, but is that bad? Because I can think of a way, that sounds good to me in a way, right? Because
if you live in northern Canada, yeah, it sounds good. I know,
it depends where you are. Yeah.
But that's why I guess you can read the book. But here's one of the effects. One of the effects is that sea level will rise. Sea levels will rise between 0.5 meter and 1 meter. That may not seem like a lot to you. Although, as I point out in the book, if I hold a bowling ball 1 meter above your foot, it seems like a lot. But hold on.
Yeah, but we'll get more water.
Sonny,
that's sea level, seawater. You don't want more seawater. And if you live in a country like South Vietnam, which is where I was visiting when I started to think about this book, where all of South Vietnam lies less than 1 meter above sea level, and the economy and livelihood of most of the people there depends on the fact that the Mekong Delta floods and produces the richest rice-producing region in the world, holding back the China Sea, which if it didn't hold back would become brackish and you wouldn't have rice. You might worry if sea level rises by 0.5 meter to 1 meter. So if you're there, there's a real issue, okay?
But overall, our effect on the planet as people, this kind of goes into our purpose of why we're here.
There's no purpose to why we're here. Disabuse yourself of the notion that there's a purpose of why we're here. we happen to be here and we're making the best of it or the worst of it, depending upon our actions as a species and as individuals. But if sea level rises a meter, what I can tell you now is unless we do something, and we can't, as Travis said earlier, there's technology we can do to try and mediate it if we're smart. And the last chapter of my book is called Fortune Favors the Prepared Mind. But nevertheless, if the sea level rises by a meter, I can tell you that about 190 million people will lose their land where they now live. And you've got to have to worry about what 190 million climate refugees will do.
You got to move them.
Well, they may move them. There's lots of things that can happen.
Or kill them. No, I'm kidding.
Well, the point is we're already seeing what the problems of migration, right, of immigration due to wars and other things on a much smaller scale. And it's already causing socio-political problems. Hundreds of thousands of people coming from Mexico in the United States is already causing socio-political problems on both sides of the border. And so you can imagine that 190 million climate refugees is a problem. But there are lots of other more complex problems that I talk about in the book that may happen. When you ask me what will happen, and there's certain things that will happen, and as I describe in the book, it's kind of like Charles Dickens's Christmas story, Christmas Carol. There's some things, there's the future as it will be, and there's the future as it might be. And the future as it might be can involve lots of risks that are much more severe. And one of them was just described in a Nature article this week, in fact, having to do with the Atlantic, one of the large Atlantic, the AMOC current in the Atlantic, that right now is subsiding because of fresh water inflow from ice in Greenland and the Arctic. And as that subsides, that flow is what currently causes Europe to be as warm as it is, because the latitude of Europe is further north than much of Canada, and yet it's much more. That whole society exists. It's much more, much less dramatic climate, much more severe climate than much of Middle Canada because of that ocean current.
Sonny,
there are lots of effects.
Yeah. Sonny, did you have a follow-up?
Yeah, I guess I do have a follow-up. My question is more related towards the planet. Do you know if it has an effect towards the planet more so?
What do you mean the planet?
Yeah.
Like, is it hurting it? Are we reverting it back to a more stage? Because I think it's actually going to help, like, trees and maybe create new land for people.
Well, I don't know how it creates new land. Some trees will benefit, some won't.
I think,
for example, there'll be areas that'll become much drier than they are now. And those areas, the trees won't be very happy. And in fact, much of the Amazon people talk about as a potential tipping point, where it could become much less, the rainforest could go away and you could produce a savanna. Those trees won't be happy.
Thanks.
So,
okay. Thanks, Sonny. I just wanted to, Lawrence, since you just mentioned tipping points, is there any one tipping point that stands out for you as a bigger issue than the rest? Like, we got deforestation, we got fish, we got, Well,
the point is, they're all, as I try and talk about in the book, they're actually all linked in many ways.
Sure.
There can be a nonlinear feedback between them. So that that's what worries me the most is that it's like a house of cards or a set of dominoes, that one tipping point affects another, affects another, affects another. And I guess that's what scares me the most, that reducing ocean currents change the climate in Africa and South America, and those things further affect the humidity levels that affect ocean currents, and there's lots of things, and the nonlinear effects that produce sea level rise from melting. The fact that in the Arctic, as ice melts, the albedo of the Arctic changes, and that causes ice melting at a faster rate, but the influx of fresh water affects ocean currents. So there's lots of tipping points, besides the fact that, what scares me is that we may be on the tipping point of Greenland ice sheet inevitably and inexorably melting, and that's 7 meters of sea level. 7 meters means that almost every major city, many major cities in the world will certainly be well underwater unless we do something.
So you mentioned in the book, speaking of the Greenland ice sheet for a moment, you mentioned about 400,000 years ago, it's likely that sheet didn't exist, or at least it had melted fully. Obviously we're going to have an increase in ocean sea level by that. Is that something that you think is inevitable at this point? Just looking.
No, I don't think it's inevitable, but it's close to inevitable. Okay. I mean, the studies now show that we're not yet at a tipping point where that melting has to continue. There's no way to stop it. Some studies have suggested that heating. The original study suggested that 4 or 5 degrees Celsius would be enough to cause that to be inevitable. There are some studies now that suggest that tipping point could be as low as 2 degrees Celsius, which we're undoubtedly going to get. But that's more uncertain. But what we can do, even if it's inevitable, by slowing the rate of carbon dioxide in the atmosphere, you can push off that inevitable melting by centuries or millennia, giving human civilization chance to mediate it or find some other way around it. Or prepare for it. So we, even those things that may be inevitable, we can push them off by thousands of years rather than hundreds of years.
Buying time.
And for all intents and purposes, that's really vital, because hopefully you'd like to think that humanity in 1,000 years could act appropriately, although I'm not sure that's true.
You seem very cynical about that, like our ability to work together on this. Have you not seen enough improvement to kind of stifle some of that cynicism in the past, let's say, 10, 15 years?
What improvement are you talking about?
Well, I mean, like the statistical realities of things just getting better that someone like Steven Pinker will talk about in Enlightenment.
Yeah, well, that's that. I see that as a consequence, as he does, of the scientific enlightenment. Sure, so that's true, but I don't see that same. I don't see a coherent. That's a set of incoherent developments coming from the net percolation of science into the way humans behave, but I don't see any evidence of global cooperation that are kind of required.
What about the Paris Climate Accord? Do you think that's just a Band-Aid thing, or do you think it's...
Well, it's words, yeah. And action speaks louder than words. So if all the countries in the world, move to the goals of the Paris Climate Accord, we'll still have enough global warming that it will produce severe consequences.
Right.
So it's better than not having the accord.
Yeah.
But it's like having nuclear weapons treaties are better than not having nuclear weapons treaties.
Yeah.
But having nuclear weapons is a problem.
Sure. Scott, you look like you're on the edge of your seat with a question. Do you have something there?
I did have a question. Well, what do you think of the prospect of like the kind of thing Elon's pushing, where he wants to set up some sort of Mars colony, and he's even talking about taking billions of his own money to set up a colony? To me, it seems a little bit, I don't know, far-fetched as opposed to...
far-fetched. I would not say... I would disagree with you completely. I think the word "little bit" should not be in that sentence.
Yeah.
And billions of his own money might get a couple of people there, but it ain't going to do much and they'll die in the process probably. But I don't see it as a solution. He has, I thought you were going to ask a different question. Recently, he's argued that he's going to give away $100 million to anyone who could come up with carbon capture. And that's nice, except again, the laws of physics tell us. I was involved in a carbon capture effort at ASU, and that's ongoing, I guess. But the effort is to try and reduce it to $100 a ton to take carbon out of the atmosphere. Now, remember, we're putting 10 billion tons of carbon into the atmosphere every year, so that's $1 trillion a year just to try. If we could do it, which we can't right now for $100 a ton, by the way. But if we could do it at $100 a ton, which would mean instrumenting an area the size of Texas with devices, then it would still cost $1 trillion a year just to keep the carbon level where it's at. I mean, that's a positive. Now, I used to think in the old days that $1 trillion was a lot of money. But now it seems that it seems like $1 trillion here, $1 trillion there, as
people throw it at GameStop.
Everett Dirksen used to say, Everett Dirksen used to say that in many different ways. He'd say $1 billion here, $1 billion there. Pretty soon you're ending up with real money. We talk about spending government money. So now it's a trillion here, a trillion there. Pretty soon you'll end up spending. So maybe, but it's 100 million is not going to. It's gonna help, but and there's certainly money should be put into research. I'd rather in some sense, although it's less dramatic, and Elon has a flair for the dramatic.
Dramatic, yeah.
I'd rather him say, I'm setting up an institute, and here's $100 million in R&D, and I'm gonna, and I'll give grants, and for people to work on the process. That might be more useful.
That just wouldn't be in the style of Elon.
That's not the Elon style. That's right.
Yeah.
I think
it seems to be made way more beneficial.
There's two people talking at once.
Sorry, Desired, you had something there?
I would say that Elon's way of going about it is the most efficient.
Okay.
It's kind of a reverse college. He's turned himself into the student and offered it in and gotten the economy to pay for his education, hasn't he?
Well, except, look, the point is you have to do this, and doing it requires money. I mean, the R&D requires... Hold on. Interest and money are two different things. So I'm very interested in fusion, but I know that to create a fusion reactor was going to cost many billions of dollars. So, yeah, there's lots of interest. I can already tell you there's lots of interest in carbon capture. It's an obvious thing to try and do. But interest and money...
One sec, Desired.
If you want to do this, you have to pay scientists to do experiments and support them and their students and their postdocs, and that takes money, and that's why governments support science.
He is supporting it. He's playing an option play to leverage the economy to put that leverage in. So I offer 100 million, and I get interest of 10 companies that weren't going to spend how many billions on it. So my 100 billion sparks that. I would say it's a great PR campaign for the idea.
Well, it's certainly a great PR campaign. Let's not. I don't disagree with you there. You're right. Look, if the vague hope of $100 million down the road is enough to get companies to spend money that have money that would spend it on something else, great. Yeah. I'm not as convinced, but that it's certainly better than nothing. Yeah,
but that's my point.
Better
than what we did before the offer came out.
And moreover, if it doesn't happen, he never has to pay it. So that's even better.
There you go.
He's leveraging the crap out of that money. He's shorting the crap out of that.
The promise that never comes to fruition.
It's like James Randi's.
Yeah. Sorry,
like James Randi's prize.
Yeah, James Randi's prize, $1 million. Prove your woo-woo.
Incidentally, the epic rap battle between Elon Musk and Mark Zuckerberg is on point, and everybody should watch it.
But look at how many people have put research into this stuff to defeat James Randi on how many different types of things.
Well, it usually comes out of the pockets out of poor people that attend the churches.
Yeah,
a lot
I suspect the hucksters would have been doing the huckstering even without James Randi. But James Randi is there to stop them from doing what they're doing.
Yeah. Dal Sue, did you have another question for Lawrence? We have Lawrence for another 15 minutes here.
I was going to ask, what do you think of Stephen Wolfram's interpretation of? Let's do like biology, where he'll compare it to a Turing machine.
He talks about cellular automaton.
Yeah.
Well, look, I know Elon Musk. I know him, but I've known Stephen Wolfram a lot longer, and I think it's misguided. Stephen is a smart guy, and I love Mathematica, but and I'm glad he produced it. But I think his interpretation of the power of the kind of underlying physical discoveries he thinks he's making, I think he's the only one that thinks he's making them, and I haven't seen any evidence that it explains anything yet. But I laud him for trying, and I certainly laud the products that he's produced. Same as Elon. I think Elon's an amazing guy, and I just don't agree with everything he says.
Yeah.
I have a question about. I think you give people a lot of credit, Lawrence, for having a pretty good understanding, in general, let's say, classical mechanics or physics in general. I think people have to move pretty slow through the data in your book, The Physics of Climate Change. And I think in some places they have to maybe take some time to create their own metaphor, their own analogy. Because I understood by reading your book that you wanted to get all the data in there, the necessary data.
Well, I mean, I wanted to be short, and I wanted people to have access to the data so that if they wanted, and also to know where they could get the data, because it's all accessible. So that if they want to go forward, and look, when I write a book, I'm not teaching people. And even when I'm teaching them, I'm not teaching them, because the learning happens out of the classroom.
Right.
A book is there to provide you the tools and motivation to have some basic understanding, and if you get interested enough, to follow it further. But I wanted to show people, because I do think in this case, a picture is worth at least 1,000 words and more, that many of the ideas I'm talking about are demonstrated by the data, and that the data exists, and you can use that and you can go to the source and use that as a way of learning. But I also I've never expected everyone to understand everything in my books. That would be kind of boring.
Right.
But what I try to do is provide enough there so that even if there's things you don't understand, you don't need to move forward. But for people who want to go into deep dive, it's there. So there's some level for everyone.
Well, it's actually one of the reasons why I keep going back to, for some reason, as I was reading it, and also as I was listening to it, because I think the audiobook, by the way, everyone, if you prefer audiobooks, it's beautifully read by Lawrence. I really enjoyed it. I thought it was great. There's even some inflection in there, which is rare coming from a scientist.
Well, I learned how to get. I know how to.
Johnny
do
Depp taught you that.
Well, I've done. It's not my first audiobook, but I was very happy that this book. Well, in this audiobook, which David Smalley, by the way, produced. But it's my 6th or 7th audiobook I've read, and it's a challenge and always an exciting one.
Yeah.
And I can. Years ago, I was able to reach the number of pages per hour that an actor could do, which made me happy. But this time, what surprised me, we budgeted 16 hours, I guess, to read that, and this time it took 7.
Oh,
I mean, it was really amazing. It took
you
less than 50% more. I mean, I was shocked.
Yeah.
That we were able to get through it that quickly, and so it was really a pleasant experience.
I was definitely wearing out my phone, tapping back in time a little bit, because I needed to recheck. Okay, what did he just say, and then add some imagery. But this is why I keep going back to calling it the Bible of climate science. I really think it is that. It's like you have all the information there. You may have to create your own imagery and your own ways of understanding the data, but it's all there. And that's the thing I like about the book.
So the book
let's hope it sells as much as the Bible. That's all I can say.
Fuck yeah. You better believe it.
What do you say, Michaela?
Yeah, Michaela, go ahead.
It's the book filled with mythology and nonsense for climate change.
No.
And if you don't believe in the physics of climate change, you will go to hell.
No, it's the objective. It's what a religious person would call their objective reality, but I would call this the objective reality of climate science.
Yeah, no, I get your point exactly. But but I'm happy if I say you must believe. No, I'm not.
How to think, not what to think.
No, exactly. I just there's the only part of it I guess that I would like is if people felt that I was God.
I think, look, there's definitely some people out there.
Look, Lawrence, you're a homie.
I'm not so sure.
Like, you're
I'm not so
great,
sure of that either.
but...
I think that'd be pretty boring too.
Yeah,
anyway,
so... An asshole anyway?
You know,
I like the Greek gods. Of all the gods, I like the Greek gods the best. But anyway.
Yeah. So something about climate change is that we do have time to plan, adjust, build up, build out, build floating, build flying. You know, we have time to adjust these things as they come. And one thing and I guess what I'm saying is you talk about the pandemic, and then you also relate how like the pandemic can kind of uproot us and change how things are. Well, I think one bright side to climate change is that we seem to have more time than with something that's going to catch us with our pants down like a COVID-19 pandemic.
Well, certainly COVID-19, yeah, you're right. I mean, climate change happens on a longer time scale, which is one of the good positives, but it's also a negative. Because things that happen on a longer time frame, it's easy for people to ignore.
Oh, yeah, yeah.
I mean, people aren't used to thinking 25 years in the future. Very few governments act for 20 years in the future. No industries act almost for 20 years in the future. And so it's a positive and a negative. But it is, but your point is one that I wanted to make, and I made at the end of the book. I object in some sense to the doom and gloom people who say the world is over.
Yeah.
And, you know, it's not over. It's going to change, and there'll be a lot of problems. But there's a lot of things we can do, and burying our heads in the sand and saying that it's over is not. I mean, I think if you know, there are people, there are well-meaning liberals in my country, like this demagogic woman Alexandria Ocasio-Cortez, who says, you know, if we don't do this, your children will be dead in 12 years. Well, that's just an awful thing to say.
Yeah, yeah.
And it doesn't help. It doesn't help. So you're right. There's things we can do, and I think I put it. And there was a review of my book in the Irish Times that quoted this, and I forgot I said it. But you know, I said the future is racing at us like a freight train, but it's on tracks that we built.
Yeah.
And so you know, there's that gives us some element of, at least some element of control.
Right. I'll just open up the room, guys, for the last 7 minutes here. Anyone have anything to follow up with? I'm sure Michaela's got a list of things.
Oh, I have endless things.
Okay.
I don't know how many of them pertain to the topic at hand, but...
Oh, okay. Well, we can all just go. I can finally have dinner, so that would be all right, too.
Yeah. Well, yeah. If you
should let Lawrence eat.
Yeah. Why don't we do that? I think we're good. I'll definitely send my review to you, Lawrence, when it's done. It'll be up in a couple of days. And thanks for stopping by again, man. It's
nice to see everyone.
And I have to tell you, you look a lot more alive, not suffering the COVID death.
Oh yeah.
Yeah.
Thank you for that.
Yeah, well, the Krauss theory this time.
Yeah.
Well,
10 years younger.
Yeah. Well, that's good. That's good to hear. Well, certainly I'm feeling good, so that's good. And I'm still waiting for my vaccination though.
Okay.
Before I can move to Canada. Okay. You take care, everybody.
Thanks a lot, man. Yeah, we'll see you.
Bye-bye.
Thank you again.
Bye.
Woohoo!
So much fun.